Now we'll do the hypothesis test in almost exactly the same way. So we're still going to assume the null hypothesis that the mean is equal to 65. But now, instead of using y bar as my test statistic, I'm going to use just a slightly different version. I'm going to use y bar minus 65 as my test statistic. Why? Why not? It's a function of my data. If you give me my data set, I can calculate this number. So that's a perfectly valid test statistic. What's the reference distribution? Well, if we use this central limit theorem, if we know that y bar follows a normal distribution with mean mu, then if we subtract 65 from every value in this distribution, we're just taking that normal curve and shifting it over. We're subtracting 65 from every value in that distribution. It's still going to be a normal curve, but now it's going to be centered around 0. In other words, if the null hypothesis is true and the population mean really is 65, then on average, I'd expect the mean in my sample minus 65 to be 0. And when I shift over that entire distribution, it does not change the variance. So if I draw a picture of this reference distribution, it's very similar to what I had before, but now it's centered at 0. When I go up or down 2 standard deviations, the standard deviation is still 0.2, so now this is 0.4 and negative 0.4. And I said that I observed 64.5 as my sample mean, so 64.5 minus 65 is negative 0.5. Here's the value I actually observed. Here's the p-value, and because I know that 95% of the time those values will be between negative 2 and 2 standard deviations of the mean, I know this p-value is less than 0.05. So that is also a perfectly valid thing to do, and as you can see, it's exactly the same. The fact that I subtracted 65 from every value in this data set, and every value in this reference distribution, does not matter in terms of obtaining the p-value. I still have a reference distribution, I still have a test statistic, and because I've done the same thing to both the test statistic and the reference distribution, namely subtracting 65, it's exactly the same test. No change. But again, if you've seen a z-test before, this is not exactly a z-test yet, although it's very close. What do I have to change to make this finally a z-test? The null hypothesis is still going to be that the population mean is equal to 65. Again, that's not something I know, that's the assumption I'm trying to test. What are we going to do? Instead of using as a test statistic y bar minus 65, I'm going to divide that quantity by the square root of the variance. So I divide this by the square root of 4 over 100, divide this by the square root of 4 over 100, which in this case is what? Well, we've got negative a half times 1 over 2 over 10, which is the same as negative 10 over 4, which is equal to negative 2.5. Okay. How did I get that negative 2.5? I took y bar, subtracted the population mean, and divided by the square root of the population variance. OK, so that's my new test statistic. What reference distribution should I compare that to? Well, we said that y bar minus 65 will usually be within 2 standard deviations of 0. It will be between negative 0.4 and 4. If I divide this quantity by the square root of 4 over 100, then that's the same as comparing this quantity to a standard normal distribution. So I can keep this picture, but now we have a negative 2 and a 2.